Kia ora, Year 11 and 12. Here are some of the easier questions from last year's Level 2 Algebra paper. I'm going to do about 4 questions per video and just finish off all of 2018. If you've got any requests for topics you want me to do more examples of, just leave me a comment or send me an email at my school address. So I've put the questions here on the front page, but I'm going to go through them one by one. There are 2 main skills, fractional and negative powers, and a little bit of algebraic fractions, and then some 2-stage factorising for this question here. So here's the first one. It's kind of a warm-up for the paper. Simplify fully this expression here. So we've got 25m to the power of 16, all to the power of 1/2. Now, depending on how confident you are, you can either hop straight to the answer or you can expand it out bit by bit. And I'm going to go reasonably slowly. So we're going to have 25 to the power of 1/2 times m to the 16 to the power of 1/2. Let's look at what each of those bits mean. Well, 25 to the power of 1/2 means the square root of 25, which is 5. Here, we're going to use the rule that a power to a power means that I multiply those powers together. So I get 5m to the power of 8. So that's an achieved question. On to part B. So part B is a little bit the same. We have to simplify fully this thing here, 4 over 3a to the power of -2. And we have to leave our answer with a positive index. So whenever I see a negative power, that means to take the reciprocal power of what's inside the brackets, right? And there's a couple of teaching videos in the Level 2 playlist on negative powers. So here, what we do is instead of 4 over 3a, we have 3a divided by 4 squared. Now we look at the numerator and we look at the denominator. And again, if you're confident, you can go much more quickly than this. Right, we've got 3a all squared over 4 squared. So the numerator gives me 3 squared, which is 9, times a squared, and the denominator's 16. So it's 9a squared over 16. Now let's quickly check, can we simplify that fraction any further? No, we can't. There's no common factor in 9 and 16. So that's our final answer. And not surprisingly, that's another achieved question. So this next one is an algebraic fractions question. We've got 4 minus b plus 8c over 3c, and we have to write it as a single fraction in its simplest form. The first thing that I want to do when I see that, partly to avoid making mistakes, is to put some brackets in, so make our invisible brackets here visible, right? The invisible brackets are given by this fraction line, right? So if we put those in, we're much less likely to make a really, really common error. So now what am I going to do? Well, the 4 doesn't look like a fraction, but we can write that as 4 over 1. When we add fractions and subtract fractions, we need a common denominator. So the common denominator here is going to be just 1 times 3c. The common denominator is always going to be the lowest common multiple of these two things. Right, what did I have to do to the 1 to get our common denominator of 3c? Well, I had to times by 3c. So that's what I have to do to the 4. So 4 times 3c gives me 12c. What did I have to do to the 3c to get cc? Absolutely nothing. So I get this, 12c minus b plus 8c. So expanding out that bracket, I get 12c minus b minus 8c over 3c, which gives me 4c minus b over 3c. Let's look back and see what the question asked us to do. Well, we had to write it as a single fraction in its simplest form. So can we see any common factors in the coefficients in here? Let's take a look. I've got a 4 here. I haven't got anything I can factorise out here, and I haven't got anything here. So 4c minus b over 3c is my final answer there. Now the next question is a 2-stage factorising thing. It's one of these ones where if you look at the expression at first, it looks horrible, and it looks like you can't go any further. So let's take a look. We've got 4bx plus 2xy minus 6ab minus 3ay. So if I look at the whole thing, it's pretty hard to see a common factor. I've got no common factor in the numbers. I've got 4, 2, and then I've got 6 and -3. and I've got B here, but no B here, and then B again in here. So it's not looking good. I've got X here, but no X's over here. So what we've got to do here is look at pairs of terms, right? And the way I do this is to draw a little box just around those first two. Let's do those first. So we're going to factorize these. And now we have got some common factors, right? We've got the numbers. We've got 2 here. I've got B times X. I've got an X common factor here. So 2X into 2B plus Y. Right, now we're going to do the same thing for the next thing. So here's the next box we're going to put around. What have I got? Well, I've got minus 6AB minus 3AY. So I can see that there's a common factor of 3. So we'll pull out minus 3, and then I've got A here and A here. So I've got minus 3 times what will give me all of this? Well, it's going to be times 2B. And now it's going to be plus Y. Okay, so we're fully factorized now. Now, if you don't like that, there's another video on two-stage factorizing, and there's some really good work on this in theta. I don't think there's much in the Walker book, but you can have a look, or I can make some more videos. But you can check this back by expanding it back out, and that might make you feel a bit more comfortable with it. Now, so here, if we expand back, we want to see if we end up with what we started with. So we've got 2b times 2x minus 3a plus y times 2x minus 3a. So expanding that out gives me 4xb minus 6ab plus 2xy minus 3ay. And that's what we started out with, although they may be in a different order. Let's have a look. No, they are in a slightly different order, but it doesn't matter. Okay, so the way to think about this, if you find it bad, is to go all the way back to our original quadratics. So when we learned how to do x plus 6 times x plus 3, you can think about that using this model that we call the area model. So here we've got x and we've got 6, and here we've got x plus 3. That's drawn very, very badly. But what we do when we multiply those things together is we take the x and we say, well, we've got x lots of all of this. And you can see that here, right? That's x lots of x plus 3. And then we've got plus 6 lots of x plus 3. And that's all of this bit here. And then we can break that down into the 4 terms, right? So, and we pretty quickly get good at just doing this. So sometimes it means we don't remember how we can represent it in harder problems. So we get x squared plus 6x, that's that one, and that one, plus 3x, which is this one here, plus 18. And then we put these two together. So when we do two-stage factorizing, we're going backwards to get the factors. Right? So the key to the method is to look at the pairs and to do this box thing around each pair and take it from there. So leave me a comment if you want any more examples of any of these questions, and thanks for watching.